I'm Anil Kumar, and in this video, we'll try to understand how to find inverse of functions. So we'll take up functions in different forms to answer this question and understand the concept. So let me begin with function a of x as, let me write it in this form, which is also called the set form. Let's say this is our function where we just list the coordinate points, right? So it could be like, I'm just listing at random, okay, 1, 5, and let me write one more point as 2, 4, and let's say we have a point 1, 1, right? So these are 1, 2, 3, 4, 5 points. You need to find inverse of this function. How do we do it? To find inverse, the nomenclature is we write a and something like this, that becomes inverse of a function. Now inverse may or may not be a function, so therefore we will not write a inverse x, we'll just write a inverse. Now when you are given function in this form, how do you find the inverse? Now you are given points x and y, correct? In inverse we just swap them, so yx becomes inverse. So that is the kind of transformation which you need to do. So let's do it and write down the inverse. So inverse will be, this point will become 3, 2. This will be minus 3, 0. This will be 5, 1. And then this will be 4, 2. And this will be 1, 1, right? So what you see here is that that point really did not change, right? So such points are called invariant. They do not change, right? Let me take one more example on the same lines. Let me call that as b of x, and let's take just 3 points, right? 1, 2, okay, and then we have 3, 2, and then we have 4, 0, right? So we have these points. Can you write down inverse of this function? Well, the inverse of the function will be written like this. We need to swap the points. We get 2, 1, and then we get 2, 3, and then we get 0, 4, right? Now clearly this is not a function, right? This is not a function, since for 2 we have 2, 1 and 2, 3. So 2 is mapped to 3 as well as 1, right? So it is 1 is related to many. So it is not a function, it is just a relation. It is 1 to many relation, not a function. Do you see that? Not a function. So there is great possibility that at times inverse may not be a function, and that's the reason why we don't really write b inverse x like we have written there. Unless and until it is a function, we should not be writing. Well, that's one way of writing inverse of a function. The other way was to use mapping diagrams. You could represent functions in many different ways, and let us say if I represent this function kind of like this, we have some values here and they are mapped to this domain. Let's say something, let me take 3 points only this time also, and let's say these are the arrows, okay? So we are mapping 1, 2 and 3 to, let's say, points a and b. So let's call this function as f. Now what is inverse of this function? Well, the inverse will be that these arrows will be drawn in the reverse order, right? So instead of going from left to right, if I change their direction, we get the inverse, right? So we get the inverse if I change these arrows like this. Do you see that? So here again, this will be called f inverse, and what you notice here is f inverse is not a function. This is a function, right? But this is not a function since b is related with 2. So so that is kind of how to create inverse of a function from the given information. Now you can also notice in all these examples that in this process domain and range interchange, right? So what we also notice is that domain and range interchange. and that is expected, since to find the inverse we are flipping or swapping x and y values, correct? So that is how we are clear that when we find inverse of a function, then the domain and range of the inverse will be reversed, right? So domain becomes the range, range becomes the domain part, right? Now you could be given a graph, and from the graph you may be asked to find inverse of a function. Let me take an example on that basis also, and let's consider the graph of a parabola. Let's keep it simple, right? So let's say this is the parabola, which you know is a function. Now how do you plot the inverse of this? So what we can do here is that we could actually reflect this on a line which is, let me just make it bold, okay, not a good line. So anyway, so what I will do here is I'll make it kind of like this, okay. So if we reflect our graph on a line y equals to x, so this line is y equals to x, we can find the inverse. So the reflection will be the points which are on the line and on the graph, they will not vary, they are invariant, and then they are reflected on this line. So reflect the graph on y equals to x line. So if I reflect this part, it will be kind of like this. Do you see that? And if I reflect that part, it will be kind of like this. So that becomes f inverse if this is my f. So inverse will be kind of like this. So in this, what do you notice? Is the inverse a function? No, it is not. It is not, since it fails vertical line test. Do you see that? So inverse is not a function in many cases. From the function, you can actually make it out. If I draw a horizontal line, it cuts at 2 points. So if the function fails horizontal line test, then its inverse will not be a function. Okay, so this is important. So what we learned here is that if a function fails horizontal line test, then inverse is not a function. Okay, so basically what we have come to know is only one-to-one functions inverse will also be a function. Do you see that? So that is what we conclude from here. This is very, very important. Another thing important to learn about inverse of function is that we can sometimes restrict the domain. So we could restrict the domain of f of x. What I'm trying to say here is that if I say only consider the right side of my parabola, only consider the right side, in that case we'll only consider the top half of the square root type of a function. Do you see that? That becomes a function. So if I restrict here that if x is greater than or equal to 0, then f inverse will be a function. Do you see that? So at times you may restrict the domain of the function to ensure that its reverse or its inverse is also a function, right? That's very important to understand, right? Now the last thing which I want to tell you is that we could also find inverse. For example, in the equation we have y equals to 2x plus 3. Now to find inverse, we have to isolate, we have to interchange x and y and then find the inverse. We could find inverse from equations by reading them in reverse order. So from equations we'll take in part 2. So we'll consider this part in part 2 of our video, right? So how to find inverse of a function from given equation, that is what we will consider in part 2. So I hope in this video what you learned is very clear. That is, if you are given these coordinate points, just swap them to get the inverse. If you are given mapping diagram, then reverse the direction of the arrow to get the inverse. If you are given a graph, then you have to reflect it on a straight line y equals to x to get the inverse. And in all the cases, domain of the function becomes kind of range of the function, inverse function, and range of the function becomes the domain of the inverse function, right? So with that, let me conclude this video. We'll further continue in part 2 to understand how to find inverse of the function from the given equation. Thank you and all the best.